I'll quickly make an introduction to the speakers from AMD. We have Mr. Vedantham and Mr. C.K. Prem here. Vedantham has 14 plus years of work experience in multi-million gate ASIC SoC function verification. He's very familiar with standard ASIC designs, flow from design concept to tape out, and he has participated in many multi-million gate SoC tape outs. He has worked hands-on with the development of module chip-level test plans and also on verification infrastructure encompassing state-of-the-art verification IPs. Thank you for taking your time to present today. Prem has 15 plus years of verification work experience on SoC subsystem and system level, and he has extensive hands-on experience in pre and post silicon validation. He has done a lot of SoC design and verification using third-party IPs. The topic for the presentation today is SoC DV using third-party IPs. They are going to cover the challenges and they are also going to provide a few guidelines. And it over to you.
So, good morning everyone and welcome to this presentation. My name is Vedantham Krishnan. With me here, my colleague Prem CK. So we are here today to present you the presentation on the topic SoC Design Verification using third-party IPs. Before I begin the presentation, I'd like to take a moment to thank the opportunity for being here at the DVClub forum and the organizer, Shyam. And I'd also like to thank the audience for present here and also those who are connected through the internet. So, as we all know, the SoC design in today's world, it's going in multi-dimensional and it's getting complex from time to time. So we'll be walking you through some of these slides. So if you have a question, please feel free to stop at any time. Or we do have a Q&A at the end of this presentation. If you have some details that you want, you can make use of that Q&A elaborately. So with that, I'm just moving to the presentation. So the topic, is SoC design verification using third-party IPs. As we all know, from time to time, we have seen this SoC design, increasingly getting complex. And thanks to the silicon technology, we now have more and more subsystems that we used to see that otherwise on the code. We're now, they're now part of the SoC, and they call it as a super system. So with this ever-increasing size and complexity, as a chip maker and an SoC designer or an architect, he really have to think about his time to market conditions. So for that, he's really thinking that whether should he design all these IPs by himself or should he really take something available from the market. I'll say when I market, we really have to source third party. So that's where we come to this context of this presentation, and that's a third party IP. So when you talk about an SoC design and also verification, we have choices, design IP as well as verification IP. So in this presentation, we are going to present you with some of the challenges if you have to work with such kind of a design and the verification IPs to your SoC. And what are the real challenges that we need to be aware of? And if you really know the challenges, there are a few guidelines that are known through our experience. How you can really work around those challenges, if you know these in advance. So typically, as a verification community, we all have to be connected together in tackling these problems, and that's where it comes to share these kind of guidelines through this DVClub forum. So now we begin our agenda with this. So this is how the agenda of the presentation is going to be. So what is a third-party IP? And when you choose to go with the third-party IPs, what are your benefits and what are the risks and challenges that you consider about? And then as we have choices on the third-party IPs that we can use it for design as well as for verification. So we're talking here more in the context of verification. So what are your verification considerations on the design IP, sir? And the next bullet we will talk about verification considerations on the verification. So with all these things done, we'll also talk about some of the execution challenges known through our past experience. So I hope we'll be able to make use of that in a larger community. So what is the third-party IP? I think it's known to the verification community quite familiarly. So I would say any design component, a component, maybe a design or a verification component that is developed by an entity other than the original developer of the hardware system. As I said, today's market, we have choices that we can definitely make a knowledgeable test to source that IP from an external source. That's what it comes to. So it's a component-based design available from an external IP vendor, and he's going to give it for a cost. And so what is this component? So this component can be one or more subsystem, or they may integrate even a super IP, and then you can source that from a third-party IP. So this is actually one of the many components that forms your SoC. And then these are all integrated to operate with the other components in the system. As we know, that's what SoC is. And when you source a third-party IP, there are two choices available to us. It can be a freely distributed, something like openware, or it can be licensed from the third-party developer for a cost. So from the context of this presentation, we talk about that's what the third-party IP is. Then there are other definitions of the third-party IP, but in the context of this presentation, what we really want to make sure that the third-party IP what we discuss is centered around this definition of the third-party IP. So next slide, we are going to the third-party IP continuation of that. So there are two broad categories, even though this is applicable only for the design IP, I would still want to give an explanation of to be more precise at what these IPs are, what are the categorization. So we have soft IPs as well as hard IPs from the design point of view. So when you talk about soft IPs, these are offered from the vendor as a synthesizable RTL, and you have permission. The chip maker really will have permission to modify the code, and you can do some functionalities for his own purpose. So example is like ARM, SATA, USB, PCI Express, the source code, depending on how your business model is going to be when you interact with that third-party source vendors. So that's the category of soft IPs. And then the hard IPs. The hard IPs are typically they are not available on your front-end, but they are going to be in the net. So when you have them, something like a hard map, everyone is familiar with that. So they are brought into the gate level net list. So typically these are available as a single file-based and then we will have synthesis, place and route close. And then, so this IP functionality, unless it's done at this level before the compilation, you won't be, the chip maker won't be able to make any modifications because it's already place. So if you refer, sure.
When we are modifying the source code and customizing for is it going to be a joint development between the original IP providers and the customers?
No, it is generally not. Because of functionality when you buy an agreement to buy an IP, there is a confidentiality that both you will enter into an agreement as a third-party IP, as well as from the developer. They go into a joint agreement, so it's generally not a partnership. But if you have a functionality that for which you need some inputs about how this in that case, you definitely have to partner. Third party. But in general, it is actually to the chip maker, because chip maker, he is doing a functional modification on his own objective. So that objective, maybe in confidentiality terms, that may have to be more explicitly into that, or it may be something like he might for confidentiality reasons. Okay. So you see from the diagram, so we really have a lot of such IPs which can be used as a component. We have even processor IPs, interface IPs, power management IPs, memory, PLL, VLS, and access. I think these are all the broad category of things that we know already that we are using in our SoC systems. Next slide. So when you chip maker SoC architecture team decide to go with the third-party IP, what are the benefits that come with it? Obviously, these are very obvious why chip maker is making this choice. So the benefits are like basically it's a component-based design that you can just use pick and play kind of that is easy to build, and especially when you have an SoC of material size, you don't want to be mangling around your own designs, trying to do that. Instead, you can bring that as a modular design and execute it, and then you are sure that that component is already there and it's going to work in the functionality as expected. Right. So you know that it also gives a benefit of reducing the time cycle because these are readily available. You don't have to scratch your head, hey, what are the how the IP is going to be delivered into the SoC package. So and reducing development costs, of course, you don't have to deploy any kind of resources for developing that IP. Better quality assurance. This is one of the main reasons why a chip maker makes a choice towards third party. When you make an agreement, it's already that the third party IP is going to commit to you the best quality, that's the verification quality as well as the time portion and everything that comes attached to it. So he's not going to introduce you an IP and to say that it's something that's not going to function, it's not going to commit. So we have definitely a better quality assurance and the increased portability. When I say portability, it's between the version to version, it's easily portable, and between the system to system, it comes with an advantage. And the interoperability. Today's systems, as you see, like they are all work under a common protocol. They are connected to some kind of a bus system. The famous one and the most familiar one being the AMBA and the AXI bus. So most of these third-party IP components they already connect to that common protocol. So which means it's a better interoperability. So if you have some systems that uses it, and that also comes through the let us say system. The IP that you are going to buy, that's also going to fit in there because that also adapts to the protocol. And easy scalability. And in this point, what I want to stress is that the IPs that a third-party vendor, it's actually a common configuration. So you can quickly the configuration standards at the time of instantiating in your SoC. And when I say that, it's also possible to take the bus with systems or maybe cases, depending on the configurability, what are the different protocols that you want to operate on. So all these gives rise to the but this is not benefits that I would say. It's not a very comprehensive one, but there are other choices, the intelligent choices that a chip maker definitely can work through that. So with these benefits, we also need to know what are the challenges when you bring them into the system. So all third-party APIs, not necessarily. Right. So if you take it from an open there's nobody you're on your own. But if you commit to a licensing and enough member of understanding entry to an agreement, that's always a process of negotiation that one has to do. And it can go into sometimes very challenging. And the risk part is also something like it can make that if you are not careful about that. Right. So that's one challenge you have to be aware of. So there are business models they operate usually for a fixed cost which are going to buy outright. I mean it also depends on whether there are multiple reasons. They may like partnership sharing cost and then the product is made. Right. So that is also a business model that a lot of people. But here the life process pretty much using the patent. They source from another vendor. So you have to pay some royalty. So all those business models which are so the negotiation unless you know how that licensing model is, it's very difficult. You will see in the later slide some of those aspects here. And the request knowledge the IP because you don't know what that IP is, what the verification, what the methodology you have. So the resources, very nice resources you have to do that. That's really one of. And the schedule estimation is really difficult because you do not know, like just buying an IP, you can be rest assured that everything is going to work. Probably not. You need to fit in that IP into the system and really see how the system work in my interconnection. So schedule estimation makes it challenging. And next point is due diligence required on a long term.
You choose an IP and with an idea, but you need to also consider the real, what's your company's roadmap when you want to choose. You don't want to go for a short-term needs and then later, you say that, hey, this IP, I can't even use it for my next generation IP. It may be a slighter variant, but I'm saying, you need to be aware of that long-term due diligence. That is really a challenge. Right? And a vendor may change its business plans or go out of business. This is truly a risk. For example, today's, most of us know that how different business models as a small startup. If you decide to go buy an IP from a small startup, tomorrow he is going to merge that company with something else. Or if you are going with really a big major IP vendor, he may acquire some of these other things. So these are all constant business model changes that you need to be aware of. And even sometimes, after just, delivering a job, and it may just go even out, it may go out of business even for a lot of business model reasons. Right? So these are all both challenges as well as risks. And the vendor may be inflexible to upgrade a component. At a later point, you really want to see that, hey, it's a minor upgrade, I wanted to do that. That the vendor will come back and say to you, hey, that version is deprecated. We don't offer support. So now why don't you upgrade to your version? So these are all real challenges that you need to be aware of. And the unknown security vulnerability. You buy a system, he's not committing that, how you are going to, how you are going to fit that IP into your security perimeter. Right? So you have a SoC, you have a specific reason how you want to architect that security perimeter. But here, what the problem is that the IPs that comes within, they may fit into that, or you may even expose some of the other vulnerabilities in the system, especially if you have some kind of the crypto algorithms or other things. So you need to be really aware of that. So that said, these are all the challenges and risks, but I would outweigh all these things against, we still have the advantages, because as long as you know all these things with the third-party IPs, we have definitely advantage that, we can make that IP model work. Vendor change business plans, actually it's very unpredictable. So you need to foresee, in an ecosystem through some kind of networking, or maybe from the top level business plans, how they are going to operate. So these are all actually some of the due diligence I'm sure most of the chip maker companies they do before they decide to go with the third party. Yeah. Okay. So the real problem now is that, okay, you have sourced all those third-party IPs into your system, but then from the verification perspective, we really don't have a guideline at the SoC level, because you are supposed to, if you have an in-house kind of a verification methodology, most of the companies have. But then, when you buy it from an external IP, you don't have, a verification methodology, or, whatever the verification I'm going to apply, there are similar parameters there. So it cannot go in one-to-one basis. So that's one of the problems that we have today. And the scattered information. I want to know, let us say, a default value of a register. Where will I look? If it is internal IP, I know there is a process well defined. I know where to look at. Even for, I'm saying, the default value is just an example. The information is so scattered that you have to refer to multiple manuals and the way, the vendor has documented to really go and find the information what they're looking for. While you go, you will learn a lot of things. But at the end of the day, you have to have that information. You don't have that, even though you have all the information, but they are not available, when you need the most. Right? That's another problem. The bugs captured at later stage involve time and cost. This is also a risk dynamic. So a third-party vendor, he has delivered to you, he keeps doing his verification at his own site. Right? At some time in the time, he's bringing a critical batch update. That's actually possible. So that is one of the most important problems that we need to be aware of, and the multiple IP vendors. So it's not that if you go with a particular IP vendor, it's not that he has the solution what you needed to architect your SoC. So for a lot of things, you have to go with some other vendors. Like if you're going to have multiple vendors who are part of the SoC system, each one having a different communication model, each one having a different licensing model, and each one having a different business model, and all those business, the risks and challenges that I have outlined applies to us. And the verification unknowns. It's typically like, we all are assured that, they believe everything is going to work, but then we are also not so clear that, whether he has done that verification, the milestones to the expectation that you are associated. So that's what the problem statement is. So I'm going to be moving a little bit quick for the time reason. So we have, as I said, verification IP as well as design. So in the design IP, I'm trying to cover some of these issues. So plan of record with the features offered, asked to vendors, reviews to critical verification aspects. So this is actually, some part it's a challenge, some part it's also a guideline that we can use it for it. Plan of record versus offered feature. It's always better we choose the latest version of the design IP, because it may be imperative that, why? That's very obvious, right? It's not actually, because in some SoC system, it may be possible that, for cost reasons, the vendor may try to sell that at a sort of lower cost. The real challenge is that you should know that, that the future plan is that, this is going to be a left direction. So you should always make sure that, you choose the latest version, even though it supports some of the extra subset of features. The extra set of features. It's still okay. Your rest assured that for your future support, that is one of the reasons you should go with. So from the verification perspective also, it's very important, because it's the latest version that needs to evolve. That the design or any bug fixes or any updates or even a better design functionality is one update only on that latest version. It's always better to choose that to the latest. Exactly. That's the near-term version releases. So we need to know, in his roadmap, when he is going to release it, because each of the IP vendors has, their own milestone. Right. So they may do a drop. Usually they advertise a drop. It's the chip maker who goes and then picks up the drop. It's not that, they always release. Yes. Correct. Correct.
How do we respond to the updates?
Exactly. So that's when you do the due diligence, you need to know the near-term version releases. What is their releases are scattered, because when they make this IP, they advertise it, hey, these functionalities are going to be in this version. If you want some more things, because you're going to compare against the plan of record, what you needed for SoC, you're going to compare against what is offered in the current version. Even the current version, like the latest one, what he has, he may have just let's say in a matter of 2 months, he may release one more major version, where you may find most of your version, most of your plan of record features, you may find it there. So that's the reason I'm saying don't go just for the latest version alone. It's important you go with the latest version, but also you need to be aware of the near-term version releases that containing major upgrades or patches or bug fixes, whatever it is. So you need to look for that. So from the verification perspective, it is very important. Why I say that it's the near-term version releases, that helps you to plan your verification plan accordingly. So, for example, a feature enablement comes only at the latest feature. If you don't know that, you will keep on doing that, and finally to find out that that feature is not supported in that version. It's equally important that you know that near-term version release. Right? The limitations. The IP, when it comes, he would have already documented some of. Yeah, that was the question.
If you in the perspective, I can just add one more. So, therefore, you get suppose we are committed to use, okay, we are required like 90% of the stuff, you may 10%, okay, there might be something, but already customers are started. You can promote also, yeah, most of them you won't get to use, but these issues of it. But if there are any issues, critical issues, we always recommend to the customer, hey, this is the version, but a major fix or some bug which is there with the performance fix or so please take this. Even though you might be one year around late in the cycle, we recommend that way, so that you are not catching something late. That is the reason. Other than that, normal feature upgrades and other things are, because as you have changed your fix, you need not migrate to the
So The limitations. So when you talk about the plan of record, okay, some of these things are, you can find that all your features what you intend to support in the SoC, they're all available there. You also need to know what are the limitations that the IP vendor has documented. Why I say that is, so you need to talk about your requirement and how it's going to interpret in terms of your SoC. Right? So you need to discuss with the internal stakeholders and track. Especially if you have a multiple IP vendors, they would have documented all these things. And when you connect these systems together, you need to be really aware of that one such limitation is it going to have some implication on the other when you are working this in an interconnected manner. Right? That's the second bullet. Silicon confidence. Most of the IPs, they are evolving, and we also know that the time pressures and the technology advancements. So it's possible that some of these IPs, maybe you have picked up have not seen the silicon yet. Okay, so you need to really aware of the risk associated with that. That's why we wanted to make some more due diligence on that aspect. To have a checklist, you need to make sure that you pay attention to that details here. Right?
In many cases, when you realize that I have my own team that can develop internal, at some point of time you might think, okay, internal was to check. As you get into the situation of our own development or IP.
Our own development of IP, no, we decide well in advance. We cannot alter the project plans just like that unless there is a commitment broken from the third-party IP vendor. Right? Because you choose to, because there's a lot of cost involved when you buy and when you make some relationship with the third-party IP, you are completely defining your own business model. So you cannot just like that change your project plan, at will, and because that's going to be a very much, in theory it may work because you can just say that, hey, I have so many resources that I can deploy to that, but it's not that easy because as I said, right, so the third-party IP definitely it achieves a better quality than what you can do, or you may have to work more to get that because it's not readily available. It will cost you to go back to that whatever are the challenges that you have faced that I showed you in earlier slide. Future projects, yes. So each project you can negotiate. Yeah, definitely. But it's decided at the start of the project. When you are, that's when you are deciding to go for a third-party company, right? Okay. So asks to vendors. So these are some of the things very obvious, but we are putting this as a guideline. What you need to ask to the vendor when you have third-party IP. So the right set of IP contacts and the escalation matrix. That's the most important one because it's always possible that you are interacting with someone who is actually not the technical guy who can solve all your problems. He is not the general contact that you can always approach because he has multiple responsibilities to work. So you need to find the right contact, and also for your turnaround time reasons, you need to have the escalation mechanism. So that is two things, and the local time zone support options preferred. This is also to help you in the turnaround time expectation. The verification metrics, so maybe the vendor may not provide. So this is regarding the design IP I'm talking about. You want to know at the vendor side, what is the verification that they have done. So you as a verification engineer, we want to ask, what is your the regression pass rate, and also some of the coverage metrics, if you can provide, just at a glimpse, but we have to really talk tough, to ask for this information. And then interpret this in terms of SoC level coverage plan, what you already have made some SoC coverage, right? Simulation specific, we also want to make sure that the vendor provides some visualization of because we definitely because it's a deprecated one, we have to ask for that support if he doesn't have one. For example, I have to initialize, let us say, hundreds and 200s of registers for each and every configuration of my IP. Then I actually that's going to cost you a lot in terms of the simulation. Right? These are some of the asks. The another thing is emulation, right? You have a design and you have in SoC, typically most companies plan the emulation work. You need to know whether this design is entirely compatible in the target platform what you're planning. And also you need to know any additional licensing requirements for this. These are not explicitly stated when you decide to make that design IP.
And the
documents, you also need to have, this is more obvious, to get the latest, latest available documents. They may just release a beta version, but then you wanted to get what is actually finally reviewed, and then, you want to have that. Mailing list. It's possible, you might be mailing that you bring to all those parties who are interested and your internal stakeholders, and where, they initiate, they have doubts or some kind of a mail communication exchange. So you need to make sure that, you develop some kind of IP mailing list within your organization. Okay. Review is critical to verification, design IP. The known issues. Do you already know all these issues are there? Because the feature limitation is a little bit different. They may not actually document all these things. So the vendor internal issue tracker systems, you need to talk, a typical example is the Synopsys, we have some internal tracking systems. So like that, there may be other vendors who will be working on that. So that's the vendor internal tracking system, and you need to interpret all those kind of things in your SoC interoperability implications. So all these things I'm talking from the verification perspective. As a designer, my considerations are different, but from the verification, these are all very tie-offs, internal tie-offs and external tie-offs. You need to go explicitly know that what are the internal pull-ups or pull-downs that they have made that configuration. It's not because you already believe that that comes verified. It's possible that your top-level stimulus at the IP level may not percolate down to that tie-offs. So it's very important you know that the external top-level port level, because you need to know how they connected the test bench for putting that IP in a proper configuration. It's possible that in your test bench, if you don't have this knowledge, you may leave some of the things open, which may have a side effect inside of the design functionality. So you need to know upfront, about all. That's why we call this as a reviews critical from the verification perspective. What are the reviews that you need to be aware of? So this will be helpful when you formulate it. Warnings. So when you pick up the design and you try to build that, you try to compile it using your simulator. So you will always see that there are some warnings. Okay, there's a linked warnings, or there may be some unsupported data warnings. You need to know very clear. You need to do your homework. What they mean actually. Because it's possible that your version of the simulator may not actually support that, so that will say a warning. And also your linting tool is very capable of it will find out some of those unconnected ports, which if you don't pay attention, it will be a problematic when you want to upgrade this IP, or you want to ask for that vendor, hey, I want to support this. You may say that that's not possible. That understand that these data types are not supported. And also, you need to know that from the simulation warnings, also this linting may come. Some of them related to the configuration. Yeah, full issues. The compilation switches. You need to know exactly, what are the compilation switches they used at their side to get that in the proper mode. And when you review them, you will come to know that, hey, this define whatever if I define, I have some other side effect in my other IP. So you need to know all these things upfront. So we may have to review that from the verification perspective, all these points very carefully, right? Okay. The next item. So these are not exactly the reviews now, but I will say the operating. I will say some of these verification aspects what you need to consider. So you need to know the customer pin modes, as I said, and the clock mode pin configurations. What is the clock expectations and all those things that may be available from the vendor document, and the interoperability. So when you bring that design IP into your system, it's not always that it's going to work just like that. Even though I said they support the common bus system, it is possible that you may have to incorporate some of the glue logic when in between your SoC bus system as well as before you connect it for your own extended functionality. That's why I said in the SoC fabric you will be doing some tweaks. If it is possible to put that inside the wrapper, it's well and good. But otherwise, they are going to be available as such for a lot of physical design reasons. They come as a module. Right? They may not allow you to move that logic. So you need to have a logic between third-party IPs. and any simulation versus modeling concerns. So when you talk about simulation versus synthesis, it's possible that that's exactly we wanted to understand what are the defines that you would use to compile a design into synthesis. What are the defines that you need to use for the simulation? It's always possible that you may have an RTL logic that you are picking up for your RTL simulation, where replace that from a back-end technology library. There's a possibility
the functionality
that
even though at later stage we have comparison mechanics like logic equals checking, which can catch. But it's important that from the verification we need to know that. The lessons learned. The vendor side. Is this IP presumably for the first time? If it is, then
we want to know if you can learn it on that. If he has silicon learning, we need to make sure that you have a particular test case that you can complete. So this is from the design perspective. So from the some of the things that we wanted to consider, I think quick time check. I'll just go through real quick. So we wanted to make sure that our test plan items cover the read write across the entire register space. You will not be affordable to miss that, because you may think that hey, he has a lot of register address. So if we have maybe thousands, and then for my simulation reasons I don't want it. That is not probably affordable at a later point. You need to make sure that you address you cover the entire register read write space, and the constraints related to 16 or 32-bit registers. With multiple IPs, you need to really know some of the IPs may use a 16-bit register, whereas your register interface is a 30. So you have to know very clear that how you are going to talk with that. I have a verification plan that the 16, 32-bit register interfaces are okay. And similar case for the internal memories, if he has. And then the qualification. When you bring that IP, the verification lead or the verification team is responsible to define how you qualify that IP to be for your curation, right? The SoC development chunk happens at some place. When you bring different new drops, some changes are being done on the IP. How you are going to define that this does not affect the overall functionality? So this point talks about this. You need to have a test list for the integration qualification. That's understand, and that brings the changes from version to version. Maybe even some basic default value. And also you need to have some kind of a basic test with the default value setting that's typically recommended. That you run that or part of the every qualification so when you bring that item. With that, I think that consideration about the design IP is over. Now I'm handing it over to my friend Prem for further. Yeah. Yeah. So usually these power management IPs, when we talk, so your decision about going with that other thing. So what is the real consideration, the power dissipation that if you want to keep it along? So if I assume that you're going to talk about whether the particular IP can be power gated or not. Sometimes exactly. So if the IP can be power gated, you need to also know the latency requirements when you wake that system out. So these wake systems and all those things that you may have already built in that, but you may have to plan some glue logic. You have some requirements at the SoC that you have a power thing, and you have the other thing. You may have to plan a glue logic. That's exactly where we talked about that glue logic requirement that you have to evaluate. Exactly. Thanks.
Good. Thanks, Vedantham, for covering most of the challenges faced, try to integrate the third-party design IPs. So I'm going to cover here, some of the challenges which we face, when we try to integrate the verification IP. So most of the slides, here and whatever the challenges we face when we integrate a third-party design IP, it will be similar. I think most of the things Vedantham has covered, so I may not cover those stuff. I have only few slides to cover. Let me go through one by one. So I've divided this verification consideration with a third-party VIP or a verification IP. It can be a UVC or it can be any BFM. So I divided this into 4 categories. So one is the general consideration,
So in that, actually, so here's the situation, right? So we have been assigned, to verify some IP. We are going to own it, and the management said that, that we are going to buy some, the verification IP from a different vendor. So what are the things, which comes in your mind, when we think about, on a verification perspective? So that will be covered in the general consideration. And second is, what we are going to ask to the third-party vendor, when we are going to start our verification. Third is a review with that, either it can be an internal review with our team members or it can be, with a third-party vendor. And fourth is a general verification aspect, what are the plans, which we can have it to cover the future verification. Right. Go by one. Okay. So in general consideration, right, I think this is somewhat similar to that whatever Vedantham has discussed. So we need to get the latest version, and we need to see is there any issues when these whatever VAP which we are buying from a vendor, and similar VAPs you would have bought from that vendors for a different purpose, whether it will have some issues when you try to run about the VAPs in our environment. And we can ask them about the next term, the same thing, the version release from a vendor. Basically, this will give some clear picture about any bug fixes or is there any patch release, in the near-term releases, right? So this makes us plan our verification milestone based upon the IP release version, right? Because you would have planned, some features to be verified, for milestone 1, but the IP VAP version, it cannot cover those features. So, this gives some, clear picture about how to plan our verification milestone. The second is the limitation. So, best thing, to discuss about the limitation is, to go with the list of the feature which you want to verify in our environment, and check with the vendor, whether these features can be verified with your VAP or not. Right? If not, then we need to go with, we can go and ask them, when these things, can be updated in your VAP. So next level is, we can discuss with the internal team members, about the issues or the limitation which the VAP has, and then based upon that, we can discuss about the schedule of impact, right? The third is the licensing. So in this licensing, right, so when you buy a VAP, it comes with a single license, but that should have been, some features, it might be enabled. Say, for example, a shadow memory or something in the VAP, which may need an additional licensing requirement. So our test plan, we would have planned something like, we want to do something based upon the shadow memory, especially for, preloading that memory. But in the later stage only, we'll come to know it needs some, additional cost. So what we need to ask. So these are all what we are going to discuss before we start the project, right? So first thing, to get a local contact. So the advantage which we face, when you get a local contact is that the turnaround time. The second thing is get a dedicated contact so that he'll be once you work close to him, right? So he will also know about your environment so that the support phase will be much faster compared to some the tickets which you file, it may go to some unknown people, or different issues will go to different people, and you may try to understand our environment and about the plan or something. It takes definitely takes a lot of time. So better to have a dedicated resource. If it is a local contact, so we can solve an issue within a day. So we can have a VNC support or something so that we can interact with him closely and we can close the issue. Right. And about the reset and the clocking. So whenever the VP comes, the reset pins and the clock pins, we have to make sure are we driving with the proper frequency in the clocking. And on the reset side, whether it's a synchronous or asynchronous, because we connect some reset pin and we'll start our test case. At later stage it may not work. Right. Then again we need to discuss with them to see whether the reset duration. Take for example 10 microseconds or 20 microseconds, whether we have to assert it or not, because he'll come back and say your reset duration is not sufficient, to bring the VAP up. So these things, we can plan in much ahead. And third point is the coverage model. So we can check with them whether the VAP which is delivering it is coming with a package, the coverage model package, or it is not. Because one of the reasons is we always think about the coverage model in the later stage of our verification cycle. Then we'll find there is no coverage model present. Then we need to ask them, and they may send it or they will say no, we are not going to support it. So it will be good if in the earlier phase of the project itself, if you ask them whether it has a functional coverage model built in the VAP or not, we need to ask them. No, the thing is, we have seen in one case in which there is no coverage model itself in that VAP. So because since we didn't do any, due diligence in the earlier stage of the project, only in the later stage we came to know there is no. Then we have went and asked them, and they provided to us. Not only constraint, there is no coding for the coverage blockage. For other VAPs and all, we got it was already there. The second challenge on the coverage model is because since that they treat us as an IP, there will be a lakhs of bins, which may not be required for our SoC simulation. So you can go ahead and ask them, like, is there any way to disable those things? Otherwise, we may need to manually remove it, or they have to manually remove it, right? So these things, because they will treat that VAP as an IP, so it will be lakhs of bins. But we may not be required. We may record 100 or thousands of bins. That is more than enough for us. So, and other thing is on the parameter side. So the parameter side, we can ask them, because if you see that whatever the model they implement, it will be having thousands of randomization part, which may not be required for us. So best thing is go with the feature and ask them what are the randomization parameters associated to the feature, and whether that is enabled in the environment, we can check. And second thing is what are the randomization parameters, whether it is constrained, for our purpose, that also we can check on that configuration parameters. And the documentation, as you mentioned, better go with the latest available documents and make sure, what are the features which we plan to verify, whether those things are covered in the documentation or not. Because in most of the cases, when you go and, ask some features which you want to verify, what are things has to be enabled, they will say some list of items which has to be enabled. But if you go back and see the documentation, it may not present. So always make sure the documentation is updated with respect to the current version, and make sure what are the things you want to verify, whether those things are already documented in the page. And third thing is, have a verification IP mailing list, which includes both the vendor and our team, to make so this process will make sure, so whatever the issues we are facing, even with the different VAPs or something, which will be visible to the other team members. Or if they have their own mailing list, from the third party, probably we can subscribe to that, so that even different different clients which are using the VAP, so what are the issues he faced, that also will be visible to us. Okay, so the next thing is about the reviews. So this we can plan in the early stage of the project. So this reviews with the vendor. So we can ask them, probably some things they may not share, about the future limitation or something, probably, but still, we can go ahead and ask about, whether this IP is consumed for the first time, whether this is the first deliverable we are receiving, or, some other clients they have it for this particular VAP. And does it have any future limitation? Probably they would have planned, to add that feature in the forthcoming releases. So, but we have to make sure, whether those future limitations should not affect our, milestones. And whether it has any known issues, which is already existing, because these things, they don't share normally, because they normally give us a thing like, okay, this is a PCA VAP, suppose all the features. But better go ahead and ask them, whether it has any known issues or not. And these are warnings. Basically, if you see, and sometimes when we try to run, the simulations, we saw some warnings like, UVM error to warning. So for some other purpose, right, they have added this UVM error to warning, but that is required for us, because that is something related to a scoreboard. So we cannot have a warning in the scoreboard if there is a data mismatch. Right? So better pass through all those warnings and have a list of them and go and check with them, saying like whether this can be waived off, or whether this is acceptable. Because these things we have faced in our simulations. If it comes with a number of warnings, we normally ignore, because we worried about only the error. So another thing is, so they will give some basic commands, which you need to add in the VCS, right? So for running the simulations, right? We run it and the test case will pass, but we don't know whether the scoreboarding is enabled by default, or we need to pass some switches. We are not aware, right? So sometimes they say like, scoreboarding by default it is enabled. You no need to pass any switch. But sometimes we may need to pass, but we are not aware. So we can check with them whether all the checkers are enabled by default, and the scoreboarding or does it have a backdoor loading support or not? Suppose if it is something related to the memory, because that is for our verification. So you can go ahead and ask instead of simply running your test case. So this will save our time. Because the first question, when the first test case passed, right? So people will be surprised to see, how the test case passed. Whether they have implemented the scoreboarding or not. If they haven't implemented, then we may need to ask them whether to implement the scoreboard, or we may need to implement our own scoreboard, right? So best thing is, since everything is hidden, best thing is go ahead and ask them whether it has support or whether it does. If they come back and say everything is by default it is enabled, then there is no issue. So, and this on the randomization perspective. So what are the fixed and random parameters which they have in the VAP that we need to have a list of it, because you cannot go through all the codes to see or repeat those points. At least what are the things we require, we can go and ask them. Definitely it should have been documented, but we need to identify where it is documented. And what are the mean and variability, right? So, for example, for the time delay perspective, we want to randomize the min and max values. Right? So we want to make sure whether those things are all available in the environment so that we can randomize in our test bench. So these data type issues, it popped up when we try to use common libraries, across the VAPs. So these warnings are popped up. We just ignore. But anyway, VAP is working. But it's better to check with them, because some things are deprecated as he explained, right, for the design, right. Something are deprecated as per the VCS, and something we may require to see these warnings should not be happening. So we normally ignore all those warnings. So what I'm saying is better if there is something from the VAP or a design IP third party, it's better to review with them to close it. It's a common. Okay, so that's all. So this presentation is mainly on the challenges, right? So these are all the issues, we have faced it. And, if you say, for example, it varies from a VAP to VAP and it varies from a contact, right? If I have a local contact, they can able to foresee all these issues much earlier in my, verification cycle. I would have saved at least 30% of my verification time. See, it took at least to bring the first test case up, it takes a month or. And but that is not exposed to us, right? So for us, they will send us, this is a VAP for us, and we are not sure, whether that is already proven one or still they are developing something. But they don't. What I'm saying is they may not disclose that one, whether it is consumed by different, different clients, or this is the first time they are, delivering to us. Right? For them, it is already proven VAP. That's how they are selling. Right? The only thing is once you get into the main issues, and when you start debugging something, and when you ask something, they say this feature is not there, but they wouldn't have told, much earlier stage. They'll say, yeah, it's not that. We'll give it on the next release. That's what this is what the comment we normally get. But if you proceed, okay, these are all the features I plan to verify it, go and ask them whether there is support. When you are going to ask them, they have to say yes or no. Right? Otherwise, it will be hidden only. Till you verify that feature, it will be hidden.
You are afraid. But here, there is essentially like, I think, very also interpretation. You pay attention to what is required at the execution and conduct this regular bonding. That's what the overall. And from the perspective of the render may not be in the perspective of what the and you don't want to expose the whole system because there is some kind of boundary that you want to that's the main
So here I see the security is on the UVM, error to warning, because once it happened in such a way, right, because this came because of the common libraries you could have used across different VAPs. So for some SATA or some PCA, for that they change this warning, but for PCA I may require this one as an error because there is some data integrity error happened, but this has converted this error to a warning. but my test case failed because of some other reason. Then only I was checking why the scoreboard was not throwing error because of this. So these things, nobody knows because we always assume everything is up and it is running. We're always worried about our test case pass or fail.
And the order of load comes in the time of the test has been defined later in the code. It might have tried, some other model might have redefined that parameter. Well, that's mostly in-house development, right?
In-house, right?
Mostly in-house. No, if you buy a KXA, some kind of
VR or something to run. There is a model, right? Corresponding model we use for simulation purposes. So the same challenges exist with model. Sometimes the model is not matches with the behavior of the model.
Yeah, that's we fix the issue. Right? You have to go through the warnings and then we need to see if the warning is acceptable or not. If it is not acceptable, then
So here,
it is applicable even to what are the models. What I'm saying is we are buying from an external what is we are can be or to be a model. Mm-hmm. Yeah, we normally ignore this one. Only thing what I'm saying, asking is this warning may not affect our test case. Sometimes it may affect, but for debugging purpose, it will be difficult. You would have seen in the warning itself when you would have got that issue, right? Instead of looking into the weights. Mm-hmm. To this warning. But normally, I don't know whether we, as a verification engineer, we run any linting tool. The time consuming. So apart from simulator as a verification, we don't use any other tools. So that is no problem we are facing. So this is something, verification aspect, which we need to have in our test plan, when we are using a verification IP. So why I'm talking about this protocol compliance and loopback test, we need to make sure whether our VAP or a UVP is because this is going to be the first test, to face in the silicon level, right? So if they face some issues, come back to us to whether to have a plan in place, for a protocol compliance or loopback. And you can have a switch test, for a different speed. And you can have these, different feature testing like in low power or error injection or support based or multi-lane test. So most of the VAPs are something to support, better to have this, in plan. Especially it will be useful, when some other team is doing, post silicon verification.
How loop that has been help you the protocol?
No. Yeah, you can have this is not a near and loopback. Near and loopback VAP is not going to help. For a foreign loopback, VAP is going to help. Because they'll be testing both. And
there's a mistake in the first IP. There's a second IP also.
The foreign why I'm talking about is, it goes into the VAP and it will comes back, right? In silicon testing, you do both the testing. One is the near and loopback. VAP is not required. Your testing the hardware is not required because it's just connecting the TX and RX lane. Other thing is that on the foreign loopback.
So the real example is you have a pattern-based loopback that you so you enable that pattern repeated compliance and you expect that that you don't have the PFP and then you get
loopback. That's a foreign, right?
Yeah, so you need to make sure that you plan all those things. So the DHC has to support that now.
I'm not sure because silicon team will say like I want some waves which you are verifying in the foreign loopback. So we need to provide that one. So for that definitely we should be supporting that one. If not, we need to go and ask them. The second thing is the interesting thing is about subsystem fusion. So when you are verifying SoC, you have a question why you want to go for a subsystem fusion. So this will be helpful when you have a design IP with two different vendors. So you're going to connect two different vendors design IP and you need to include some glue logic over that. Better go with a subsystem DV level verification, before you go into the SoC. This may weed out, a lot of issues because have two different design IPs from different vendors, and you're going to apply glue logic over that. You better go with the system level verification before you get it integrated in the SoC. So here also, you can have some coverages, which you can collect it, make sure all the systems are verified. Because it depends upon the SoC. The SoC is telling only one vendor, design IP is, but if you have multiple vendors, then probably the better approach will be, going in the subsystem verification. Based on the version compatibility. So, so when you're getting a verification component, a different verification component from the same vendor, it comes with the package, right? So it says in a VSP package, and it has, PCA, AMBA, SATA, and those things. Most of the places they use common libraries. So some of the ports, include package and those stuff, will be there in both of them, script, when you try to compile it. So we need to make sure, because it's also in a way, because they would have verified in a separate way, like, the SATA VAP separately, they would have compiled it, and the PCA separately, they would have compiled it, and they would have verified it, and they put the package and they will send to you. So when you try to compile both, you may face some problem in the version incompatibility. Probably, once you find the issues, probably you may need to get a next version release. And the better approach can be, and another approach problem is, you get a package, a VAP package from a vendor, and you get a patch for different IP VAP components. Say, for example, you got a patch for a PCA, but you got a VAP package in a different version. When you try to compile, also you will face a problem. So better have a version control in your Verif environment, to take a particular version of the VAP package and a particular version of the component package. So that way we can solve this. So third is about the simulation performance. So when in the SoC level, you may be verifying, 3 or 4 VAPs, definitely it is going to be our simulation time. So best thing is, if you don't run any system level scenarios, if you're targeting only one IP, say for example a PCA or a SATA, better try to disconnect to a simulation or to simulation. So that way, at least you can solve most of the issues. You see some of the say for example PCA, even though we are not running, it is already connected to system operation. It's not required when you run for the other. So those can be emulated, because that also a lot of debug statements in the simulation log, which will go down in your cycles per second in our regression area. So better to have those things, because you are going to target only one few from the system level test. So remove all those simulations is the better option to get a simulation performance. So based on the verbosity control, So you can have your message, because it also has high or low verbosity control. Some of the VAPs, right? They have wrapper over the CM code. They may need to hard code some value. So the comparison side. So we can see, how much we can control that, control, when you run a simulation, they use something like Verilog wrapper over that. There are some tasks to implement test time, increase that, control or debugging process. Okay, so this not only it is a general talking about coverage. So normally, right, when we think about some IP, design, we don't think about the technology, which is attached to that one. It's attached to our software. So have coverage check the glue logic implementation. That way we'll make sure the software implemented in the software, verified, and you can have your own function coverage. Always rely on the VAP, right? You can have because VAP will only whatever the stimulus which is targeted to the VAP or which is transmitted out of the VAP. Better have a system level in place, a function coverage which can encode it to make sure your feature is covered. And in verification means whether you have an which can collect the coverage in the wing. And even for IC toggle can be taken as a sub IP or a function. Have a waiver list in place. Do do a thorough review with the designer
and make sure
and see
what are the
what are the
framework
frameworks is correct.
Same thing
And the
like
same
that
thing can be applicable even for the DEP coverage.
So
So
just collect all
collect
this
all this
DP
DEP
coverage
coverage
which are
which
not
are not hit,
the thing it
thing
is
in
not
it is not relevant to the feature,
or
go and set up a review
with
with that third party vendor
and make sure
and make sure those are weighed properly.
because even
Because even most of the time we don't worry about
coverage waiver
we
simply go ahead and
simply go ahead and waive it.
not done.
Not relevant. Better go ahead, have a review with them and
Thorough review with
thorough
them.
review with them. You are saying
Those waiver lists.
those waiver lists.
And
And as part of the
content, right?
content,
So
right?
normally
Normally,
long short
short
initial
initial cases. Most of the resolution, what we are trying to run will be short initial cases because because of that the simulation time, right? We don't want to run for 2 or 3.
But if you see
But
on
if you
a,
see on a
design verification
verification
perspective,
process,
long
long
initialization
initial
case is
stage is
required.
required.
Because this is
Because
what
this is what
we run in
we
the
run in the
silicon.
silicon.
We normally
We
don't
normally
care
don't
about the
care
long
about long
initialization.
initial
So better to have two separate
separate
registration batches.
batches.
Some test
Some
cases
test cases
you select it
select it
especially for the long
for the long
initialization,
initial
try
try
to
to
run
run
it.
it.
It
Even
takes
though it takes 4 or 5 days,
sometimes
sometimes it will catch up.
and this
And this
mapping
having
this on the DV
from the
perspective. So
perspective,
you
so
have a
you have a
CF
CF
plus the
plus the
UVM.
UVM,
See,
see
whether you can pass
pass
the message
the
between the
message
CF
between a CF and UVM for the better controllability of the test case.
because the
Because
CF
the
running
CF running
here
here
with a cause of something is separate.
separate now.
Since you need
Since you need
both
both
the
the
stuff
both
and
the stuff,
have a
have a
controllability,
controllability,
passing some
passing
message
some message
within the
within
CF
a
as
CF
opposed to
to
the
the
EVM.
EVM.
The second is the
Second
error
is the error
reporting.
reporting.
So
So
have
you
a
have a C++ test case running here, and it has a lot of
statements and
statements
you
and
will be
you will be
separate.
separately.
And see whether you can
Whether
have
you can have
separate log for each
log for
test
each
cases or keep it
or
as a
keep it as
common log
common
like
log
infra support.
cross
So
support.
that
So
the best thing is
best thing is
personally I feel is
personally I
to have
feel
a
is to
separate
have a
log
separate log
because
because
otherwise
otherwise
same log will be
same log will be
it is
difficult to
read out
read out those.
so
So
anything
anything available for the error report.
At your IP level, you have design IP. Your EVM components are driving on the outside. Once you introduce IP to the SoC, your C will drive, I mean, to processor it will drive. How are you going to reuse that input side UVM here? Because now, even by C, we are writing everything right to solve
No, the IP level and
whatever
whatever we discuss, when or verification on the SoC level, IP level and
So, then
DSP.
why you are talking about the UVM here?
No, this is on the SoC level. Let's say, for example, any IO devices you have, you need to drive that, or that you need a
What we
UVM test
only
train.
where is the periphery of the chip.
yeah correct
Yeah, correct. These are all related to
So
IO.
most of the time,
Not on the
not
internal.
active.
yeah right
Yeah, right.
yeah this is not
Yeah,
the
this is not the
IP,
internal
this is
IP,
not the
it's
IOs.
on the IOs.
Verification IP is
Say for
Say,
example
for
you have a
example, you have a
PCI
PCI
controller
controller in your
SoC right
SoC, right?
so you need to
So
have
you
an
need to have
endpoint
an
or
endpoint or something on the test bench
so that
side.
is going
So
to
that is
drive
going to drive. That is on the UVM side.
and what are the
And what are the
processes
processors
you
you need
configure
to
or
configure or control will be on the same
so
side.
you need
So
to
you
have
need
both
to have both.
yeah, but if I verify PCI IP as IP,
IP
IP.
on the AXI side also,
that you need
That
and
you
what
need
are
a
the
two
VAPs in place
VAPs in place to
but
do that.
whatever you
But
are
whatever
driving
you
on
are
the
driving
controller
in the
side
controller side, it's not required.
right
yeah, that is not,
Because the
but I don't want to use whatever I already developed. I don't want to throw that one.
yeah that is
yeah,
what
that is what. So on
controller
the
side you may
controller
not
side, you may not
able
able
to
to
use it
use it, right?
because
Because
the
the SOC
SOC
it is going to
sitting
again
there
sitting there on the other side,
on the VAP
not the VAP.
but for the
But
on
for
this
the,
side
on this
it
side,
is using as a
using as a
responder
responder.
Controller side, here your UV is driving the traffic, but it's going to your AXI bus and going to some endpoint.
yeah correct
Yeah,
yeah
correct.
That's
Yeah,
on the IP
that's
level.
on the IP level.
On the controller side, what is doing, that is very intelligent UV component.
Yeah, correct, correct. Mm.
I want to use personal machine side also.
No, that is not.
no that is
No, that is not possible, right? Because this is where your processor will come into a picture, right? Your system will come into a picture.
yeah right.
Yeah, right.
Whatever my controller side UV is driving, that means somehow I want to capture the stage and I want to get the and I want to do the thing like if anybody is doing
So UVM to C conversion, whatever the stimulus you are developing.
okay, so we can discuss this I think
No, mostly you will be doing in a C, you will be only bringing that controller up, right? It's going to be a register program. That's what you are going to do. Yeah, right. Mm. Mm. But okay, so I have a but do we need to run all that in this SoC level scenarios? Yeah, that's what. Some configuration we need to run, that we need to put it for the C, but not all the sequences you're trying to do it on the IP level, right? But I don't know whether. Yeah, correct. That. But it should have a SoC level importance on that, right? See, mostly your initialization routine will be common. Either it is on the IP or
Because different configurations, different instruction.
so PC initialization is going to be a common. Okay. Okay, that's fine. Yeah, that thing we need to put it on the C. There is no other doubt because that is recorded on the SoC level. Yeah, we don't need to put that. Yeah. Okay. Oh, that is.
Where my simulation is going, I don't know. Because in my LSF view, I have different missions. Okay, if I use DPI, so that is my server internal memories. So those are some are data, some are different levels. So this is very unstable, and every time I'm getting the what you call stack trace. It's impossible to debug, and I have to call the random tool list, and the time we're starting to my RMD. Then you have a lot of malloc calls in your C. Right? So you need to actually constrain that malloc calls to fall within the particular region so that it doesn't go into stack trace. Because yeah, we can talk about this specific problem if you wish to. Yeah, so I think.
Okay, so the final about the normal execution challenges when you face when we try to execute for the first time.
So the first time,
right IP contact,
we have to make sure
at least that we are interacting, he has some experience on that particular VIP, whether he wants something on VIP or not, whether he's an owner.
So that way,
right? Decision we are making, it will be closed as early as possible.
So the
unverified IP is not known. This is something as I discussed with you, so we go with some, try to do some verification. Finally, they came back and say this is not that, but so better thing is, as I mentioned, go with all the features.
In the first was
before integrating that environment, what are the different, verify, make sure that is already implemented or not.
Or else
we may
how much it will
affect our verification milestone based upon that take a decision.
So other thing is
the from the design side.
You see,
like most of the design is provided by the vendor. Places they are second level itself, all the codes are protected.
So debugging
will be always level something happening after we don't know what's happening.
So this is something
challenges
you normally face.
You need to live with that. I don't think there will be the actual design code to us.
Right. And another thing is that so as a SoC, if you have a number of fibers, and
number of VAPs
plus your
AMBA VAPs based upon the protocol, compiling multiple VAPs, and then it takes a lot of build time,
and it has
time overhead,
and we need to see how we implement our team. Even though it is from the same vendor, will be having a UVM something will be having wrapper over that. So these are all the we try to multiple cases. Last one. So some of the design last one that will be during our test we get some error so the thing is make sure whether as or design, make sure everything is for design. So this can be done only when you are collecting the information from the vendor. Right? And the one is the non-availability, right? The later stage, if you come to know there is no functional coverage implemented, it is going to be time consuming because if they want to provide it will take 1 or 2 months, but by the time we will be nearing our takeover time. And there is a non-availability of feature documentation. So they will be giving a number of documents, but
I'm damn sure nobody will go through all the documents. We'll go through based upon the future, and at some point we'll realize there is no future documentation present, and all the features, whatever they display, I mean, they will give us through mails. So make sure all the features are present in the documentation which is delivered to us. So this is applicable not only for the design IP, even it is for the VAP. Yeah, that's all from my side.
Like some of them are the EVC, some of them SoC, some of them are the IVDM.
Yeah, actually, we got a chance to work mostly on the UM side. With one is on the bind statement, which can be stitched into the RTL, and something on the Verilog wrapper. Even though the inbuilt stuff is an UVM, so sometimes you can call that UM sequence. Sometimes you can call the Verilog task. So these are the varieties we worked, but not on different languages, which I don't know whether people will go for that.
You have a system Verilog wrapper that you can interact with HDF, because you can always use only one language to connect from that.
Go with a single vendor. That is the best approach.
Yes. But if you have a legacy IP, I have a license not like that. Exactly. If you
No, go.
legacy IP,
Also, all the areas are inside run statement, and then they have UM wrapper. Okay.
No, go with a single vendor.
I have gone to the statement, and I did have like a statement license extra, and moreover, because we have multi-billion gates, we cannot afford to run all the archive information, so some of them will definitely switch models. At least your what we call cross-sell models or models, so
yeah, correct.
We use different languages.
yes. So
But the guidelines for the yes, so everything is definitely not guidelines.
no, not guidelines. So what I really mean here is that your top level test bench, if you have a list of all those different language support, I think system Verilog is and the UVM component is the one that can unify across all these. You need to plan, just like the glue logic that we plan in the design. I think you need to have some kind of a glue implementation and how you are going to use the message passing and all those things. Typically, you can use a shadow memory model kind of a thing. Message pass, these kind of different languages, because everything. Then your randomization plan comes into picture. You can use some kind of this C-based or a file kind of a thing where you go altogether different. You use a Perl flow for all your testing, because Perl is something that you can use the inline Perl and then to generate all your randomization functions, and then you feed them as some kind of a definition size for this VAP. If you are looking at the randomization side, because let us also understand that yes, the unification of all these different verification language IPs, that architecture we need to understand. That has to be planned from our side. So the different VAPs, as I said, like the segment, they are delivering. And that's one of the best verified component that they may have already developed, and we want to definitely use that. There's no portability that I'm talking about there. But you have to see, how you can use your top level TV to use that randomization constraints what the VAP expects. So you have to have your own kind of a homework to do, how these different parameters. So the best way is to use some kind of a Perl-based verification methodology, where you can generate and you can integrate all these components. It's just a text flow, and then you can pass it for a different configuration. So that's one of the ways. The other way is you can use actually some kind of a system, your memory model. You have a dedicated particular place. You can do some kind of a picking function, so that if one VAP writes to that thing. But if I say that they are not portable. They're not portable. You have to be really accurate. You need to have Verilog IOs to capture those inputs and outputs.
You will be facing the licensing issues, right? When you are firing an LSF, sometimes you may not get one license. Your test case will not proceed.
No one solution that,
See, it all depends upon the management how it is going to decide it. So go with a single vendor. Go with whatever the methodology you want it. That is the best way. But as you mentioned, if management is not supporting, we have to get a different IPs from a different vendors, different license.
If I take ARM support only processor, definitely I have to go for ARM for one processor. So if I go for another like PCA or then I have to go to definitely second one. And if I have system C, mandatory I have to use the UM connect. This was mandatory. So
Probably.
You still have the UVM there that you can use it to or a system Verilog. Basically, I won't call you this my personal preference is a system Verilog, and you can use it as your top level test strategy. and then use that to.
Yeah, what he's saying is that the test bench strategy, right, will be difficult, compared to if you have the same VAPs in place, right?
Yes.
To connect to those VAPs, if you have any message passing or something, that's what they are.
And again, this every VAP is some kind of VCC.
version.
And different tools will different VCCs, and our similar will different VCCs. If my LTLMP path is not proper, that's it.
Then we need, then we need to ask those definitions, the pre-compiled libraries problem, whatever we have said. So this is exactly aligning to that. You have to talk to the vendor and ask them to give, hey, give me this binary in this VCC compiled.
So if I change the LTLMP path variables, it will work for one component, it's another component will fail. Getting multiple guys and getting the same VCC version, all the components, very big painful.
Yeah, right, okay, yeah. I think most of questions are done, I think. Any specific questions?
Yeah, we can take it.
That's fine. Okay. Yeah, I think we'll take it offline. Okay, thank you.